So example, sigma 2i minus mu squared, I start from 1 goes to 3. Evaluate this when mu equal to 2. So now they're asking, what is this one? So the purpose is we just want to confuse you, so don't do it very well. Asante, very nice, we attended again. Let's see. So what do we get here? All right, your CEO is here.
Hi, Professor.
Hello. So something is missing actually. I start from 1, then goes to 3, I said. So in order to do this, so the first package is kind of complicated, but they said mu equal to 2. So what you can do, you can just erase this mu, just put 2, because they said it's 2. So I'm gonna just put 2 here. So now I'm gonna expand it. This will be parenthesis 2 times 1 minus 2 squared plus 2 times 2 minus 2 squared plus 2 times 3 minus 2 squared. And I stop because this is 3 and 3 is right over here. That's the maximum number I can get. This will be 0 squared plus 2 times 2 is 4. 4 minus 2 is 2 squared plus this parenthesis 2 times 3 is 6. 6 minus 2 is 4 squared. 0 plus 4 plus 16, which is 20. All right.
Thank you.
Sure. It's too late. Yeah, you took this. Kenda, was you? Does that make sense? Kenda?
It does. Yes, it does.
Did you do, okay, well, so the question in exam is similar to this.
Yes.
Take it after dinner tonight. Ray. Good.
Hey there.
Good to see people, man, instead of only name. All right, so let's, we are in the statistic part, we are in part of the statistic that you need to solve. That means we need to review algebra more about how to solve the equation or two equations, two unknown. Let's start with, let's get some idea about equation. For example, 5x plus 9 minus 3x plus 4. We don't call this one equation, we call it expression, and they ask us to simplify. I mean, there is no way we can solve for x here because there is no equal sign. Just ask us to simplify. So simplifying means we're gonna collect like term. We have 5x here, negative 3x there, then you can, so you combine x by itself, we get 2x, then we have 9 over here, 4 over there, we combine them, we get plus 13. So we simplified it to this form. Nothing about solving, simplify. But solving happens if I have like 5x plus 20 equal to 45. Now we have an equal sign. That means for what value of x, if I plug it there, the left-hand side will be equal to right-hand side, will 45. So we learn the steps, correct? We said we have to isolate x one side. We said we have to have, so there's a strategy that x should be one side of equal sign, everything else the other side. Then we're done. So we need to take, we have to remove, we have to get rid of 20, and then we have to get rid of 5. So we're going to minus 20, minus 20. We get 5x equal to 25. Then here's multiplication. We divide by 5. Then x equal to 5. Good? Then we're done. We went through this a few weeks ago. If you have question or if you have difficulty to solve a question like this, please call me, email me. We do something. I mean, this is a one equation, one-on-one. Now, if I ask you guys to solve for x and y, we have 2x plus y equal to 18. So so the question is solve. The first thing we should ask, is that possible to solve? Ray, are we able to solve for x and y?
No.
I like the motion, very relaxed. No, very good. So we are not able to solve for x and y. So we have one equation here and two unknown. X is unknown, also y is unknown. So this is not possible to solve. Previous question, only we were missing x, one unknown. So I mean, you can say x equal to, for example, 10 and y equal to -2. If I plug this over here, I do get 18, but somebody else gonna say, oh, x can be like 5, then y can be 8. Again, if I plug it there, I will get 18. You have infinite solutions. There is no one unique solution. So at the beginning, we're gonna say that this is not possible to solve. In this example, we solve for x. That means if I plug 5 over here, there is no negotiation. I will get 45. There is no other options I have. That's a solution. So now when we have two unknown, we need to have two equations. So now 2x plus y equal to 18 and x minus y equal to 3. So now we are dealing with two equations, correct? This is one, that's another one. And we have two unknown, x and y. So this is possible to solve. We cannot just solve it in a few seconds, but I mean, we are able to solve it. Any question here?
Yeah, where did you get the 3 from?
Very good. That's the part of the question. This is part of the question. I mean, this is a question. They call it system of equation. So we have two equations, two unknown. My question to you guys is that yes or no? Are we able to solve it? Are we able to come up with x and y? Yes, we are able to solve example. I was watching the news, the debate right now. Yes. So the answer is yes, we are able to solve, but how do we solve it? That's a different story. Because we have two equations and two unknown, we are able to solve. There are three different methods to solve two equations, two unknown. I'm assuming that you guys learned it in algebra. I don't want to go to the details, but what you need to know for the statistic, you should be able to use elimination for this. So there are three different methods. One of them is graphing, substitution, and elimination to solve for x and y. Anybody solve for x and y here? Who solved for x and y? So in order to solve for x and y, don't freak out. Don't think this is like a calculus 3. No, it's something that you need to refresh your algebra part. In order to solve this system, one way is to add the two equations or subtract them to eliminate x and y. Here, if I add top and bottom, if I add them, 2x plus x gives me 3x. Y minus y is gone, so I eliminate y, equal to 21. 3x equal to 21. What is x?
7.
Thanks, Stephen. So you divided by 3, x equal to 7. We solve for 1. What is value of y? How do I solve y?
Plug 7 back, or plug 7 in for x in one of the
Now
equations.
I'm going to plug this. I get the x equal to 7. I go all the way to the equation. I plug it to any one that you like. I pick, for example, this equation. So we're going to have 7 minus y equal to 3. Now we have one equation, one unknown. What is the value of y?
Four.
Very nice one. Y equal to 4. Probably he did it in his head, but we can just subtract 7 from both sides. We get negative y equal to negative 4. Then divided by negative 1, you will get 4. So x equal to 7, y equal to 4.
I wasn't even thinking that was the easiest one, because I just went ahead and plugged it into the first one, and I you know, it was, of course, it's the same answer. So.
Oh, you put in the first one?
Yeah, in the first equation.
Well, for sure, if we get, for sure, we're gonna get same answer. If we don't get it, something is wrong with the equation. So you got the idea that we need to have extra equation for two unknown. X plus y minus 3z equal to 4. X minus 2y plus 5z equal to 18. Are we able to solve this system? Is that yes or no?
No.
This is not possible. Why is not possible? Because we have two equations, but three unknown.
Yeah.
So we need to have another x plus y minus 4z equal. Now we are able to solve it, but how do we solve it Again, this is advanced algebra, but we don't want to go there. Maybe you should know this as well. All right. This is a story about algebra. I make more example like this for 2 equations, 2 unknown. There is an exam you need to take for Math 800 by end of tonight. So we're going to go to a statistic. Let me review what we learned about the statistic. So we learned that we have a population. Please stop me if you guys have any question or complain, anything. Let's say this is a population. We would like to find the average height of entire people in the earth. But you know it's not possible. Good? What we do, so this will be the population. What we do, we need to take a sample. So I take a sample. This is going to be sample. Let's say 500 people. And I find, and we do a statistic on that. A statistic means descriptive statistic. We are able to use our calculator or phone to add all the height and divide it by 500 to get the average height. For example, from sample 1, I get 5.2. So can we, with one sample, are we able to conclude that the average height of entire Earth is 5.2?
No.
No way, correct? It doesn't make sense. With 500 people, with 1 billion people. So we say no. What we do, so we're going to apply inference. So we study the sample to get an idea about population. What we do, we pick another sample. The sample, so we are assuming the sample is great, is not biased. We just randomly, we pick 500 people. This is 500, all of your samples should be 500. So this is gonna be like a sample 2. We get another X bar 2, I get 4.8. Good. With 2 samples, we are not able to make a decision for entire Earth. So we do this sampling. We take like a 10,000 sample and we graph them. So X3, we have X4 goes to X1000. Each one has value. Are you guys with me? Musa, are you with me? Are you my sample or not? You should be in one of the sample. You are a tall guy. Let me put like a 7.2, for example. So we get the sample, we plug it in our small machine, and then we get the output. Now we graph them. Correct? What do we call them? Because sampling distribution, we graph them like here we have 5.8, then 6, 5. So they are, each point here is one of them out of 500. So when we plot them, one going to be here, here, here. But interesting, if you take a lot of sample, the data will be something like this. I mean, a lot of them will have a similar, not far away distance. So now we're going to make a conclusion. We're going to say this, the population, the average height of population should be around the mean of sample distribution. Those are the sample distribution. So if here, for example, it's crowded, so we're gonna say it's not gonna be 5.8, it will be some interval around here. All right? So if there are a lot of them are like a 5.8, again, we are not able to say the average height for the Earth is 5.8. We cannot do that. What we say, we're gonna find the interval. We're gonna find the standard error here. We're gonna say 95% we are sure, for example, the average height will be between 5.72 to 5.80 or 9. So we say 95% sure with this distribution, the population average height will be over here. This is a sample distribution, has a mean, also has a standard deviation. The standard deviation same as a standard error for population. And the 95% interval, confidence interval will be plus minus 2 standard error, which is this one is margin of error. So it will be like X bar plus minus 2 standard error. So you need to understand this, and you need to have this guy inside of your note sheets. Any question here? Does this make sense, just visualizing the?
Yeah, I can visualize it. It helps.
Very good. But today we're going to learn something cool. Today we're going to learn, let me tell you guys briefly. Okay. What is this? I have no idea. I don't know. So we have a population that we are not able to apply a statistic to it because we are not able to get all the information. But we are able to find a sample. We get one sample. Good. Somebody proved that we are able to come up with some conclusion with one sample, we are able to make a decision about the population.
That seems impossible.
Nice, you're following me, very good. But it is possible. I mean,
How so?
You will see, very good. I know it's impossible.
Because I am not convinced.
I know.
I'm not convinced.
Very good. So we do like this. Just let me see if I can explain it. We find like 5 people, good, 5 different heights. But let's say this is 500. So now let's say we were only to get one sample, and we are not able to get any more sample to do what we know. So you just focus on this sample. Good. What we do now, okay, we pick another sample from this one. So let's, this is, I'm going to call them A, B, C, D, E. Let's go with 5, okay? So with 5 people, we're not talking about the Earth, but our sample is 5, and we would like to see, are we able to make a conclusion about our population? So one person said, these 5 people is a sample, I pick another sample from this one. But the way I'm going to sample it, the way I'm going to make a sample, first, for example, these 5 people, I put them in the bag, correct? I'm not going to see what is in it. So I put my hands in the bag, I pick A. Good, I list it. And I put the A back. So I put the A back, but I record it. I get another person. I might get another, same A again. So I pick
Oh,
5
I
people,
see.
B, and then probably B, then I pick D. Good, so this is gonna be one sample. Then I make another sample like this. I make
Oh, I
another
see what you're
sample
doing.
might be A, B, C, C, C. So those, for example, so, but we're gonna have 1,000 of that. So with 1,000 of this, you're gonna say, oh, these 1,000 of people, they might be somewhere in this population. If somebody randomly pick another sample, A, B, C, C, C might be one of the sample of the population, correct? But so what we do, they call it bootstrap. With one sample, we're gonna draw a lot of sample by placing it back. We're gonna go over this today, but that's the idea.
Okay.
But we might have more error. For sure, we're not gonna say, oh, we're 95% or 98% sure the population's like this. No, we're gonna have more errors, bigger interval. All right, so this what's gonna happen. Okay, we have time. Let's go over a couple of homework questions. Okay, let's have some. First question. Can you guys read or is it too small? I know some of you guys don't like word problem, and the statistic is all word problem. So try to deal with it. Don't think it's complicated. And don't think you need to read it once to answer it. No, you need to read it 10 times. You need to look at your note sheet to understand all the definition of the wording here and then make a decision which one is correct. For example, I'm going to ask Musa. I don't ask him that much, but Musa, is this parameter or statistic?
Oh my goodness.
I know you need to read it, so there's not enough time to read it. Please let me know if somebody answered this. Catherine, you think it's parameter or statistic?
I think it's a statistic
This is
because it has the
I'm
third.
gonna have to agree.
yeah, is a statistic. So parameter is something regarding the population. A statistic is a sample. So all you need to do, you have to say, is this a sample or a statistic? They're saying this much. That's not the population. So they study only that, 7,335. So this will be a statistic. Very nice. Okay. Now, the margin of error. Look at the sentence has so many keywords. Each keyword you should have not a page, at least a note card regarding the margin of error. We don't want to do a mistake. There's some of them are super similar.
Is it plus and minus 7,335?
Well, which formula did you use? So this is our sample. This is our n, correct?
Yeah.
This is our x bar, for example. 30% has, this is a sample average. We learn the margin of error is 0.01, margin of error, good? What we have, the formula said, x bar plus minus 2 standard error. This is one of the formula. Another one, we have x bar plus minus margin of error. So we have 2 formula for 95%. Which one should we use? We never talk about n. N is a sample.
We use the top one.
Do we have a standard error or we have margin error?
Oh, we have the margin of error, so we use the
Margin.
bottom one.
Very nice.
Okay.
Very nice. So the answer is going to be 0.3 plus minus 0.01. Correct. So this gives us 0.3 plus 0.01, 0.3 minus 0.01. So this gives us 0.31, 0.29. Ray, does that make sense? Kendall, does that make sense, Kendall? Musa for sure makes sense. I'm gonna pick Sierra.
Hi. Yeah, I mean, it kind of makes sense.
So we are just following the rules. We're not making it complicated. I mean, in exam, and this is a homework question, and exam is not going to be more difficult than this. But the way you are, I mean, you need to have this in your note sheet and write about the details, the margin of error. Don't do a mistake with the standard error. And we don't use n. N is something, the number of sample. So we are trying to find 95% for the parameter. So it will be, that's what we do. Let's have part C. Is that yes or no? Given the margin of error, so the margin of error was 0.01, correct? So now the question is, so we find the interval. So for example, 0.3 was here, 0.29, 0.31. So that this is an interval, correct? We find on part C. We said we are 95% sure that the population, it will be between this interval. Good. 0.3 was from the sample of 7,325. We applied the standard margin of error, we got the interval. And we said 95% sure the population gonna be there. So now, is that yes or no?
No.
25% is around here, is less than 0.29. So the answer is no.
Oh, yeah.
Correct? This is how it makes sense if we know the word, all those terminology. Ray is admit again. Any question here? Catherine?
Sorry, I had to step away. I'm gonna go back and watch this on YouTube. Watch that section.
That's okay. Okay. So let's move to, so you mean I have to put this on YouTube? Wow. So let's move to another question. This one. So word by word, you're going to read it. All the words should make sense. If one doesn't make sense, you have a problem. Let's forget about this guy. So we have a standard error, 6.1. Average number of text message. So here they said X bar, correct? Should I put X bar equal to 41.5? This is a statistic, correct? Because we're dealing with the sample.
Yeah.
So here going to be 4.41.5. Use the information from the sample to give the best estimate. So what is the best point of estimate? This is the best point of estimate for population parameter. So X bar is here, correct? 41.5. We have all the sample distribution, correct? Sampling distribution. We would like to make a decision for population. We cannot say 41.5. We're gonna make an interval to say, oh, 95% sure they are between these points. All right? So A is that. Now let's go to part B. Find a 95% confidence interval for the mean number for the text messaging. So now we're dealing with interval. That means we are looking for this and we are looking for that. You have two formula. One of them is X bar plus minus 2 SE. Another one is X bar plus minus margin of error. So which one do you want to pick?
The top one.
Top one?
SE, standard error.
Very good. So we have a standard error. So this is a good candidate. So we're going to have X bar, which is 41.5 plus minus 2 times 6.1. And we don't want to do algebraic mistake because this would be horrible. We have 41.5 plus 2 times 6.1 and 41.5 minus 2 times 6.1. I think we should get 29.3 to 53.7. If you entered 53.7 over here, 29.3 over there, you know the system gives you error. So don't email me, text me, don't call me. So I did it right, but my program is broken. No. Any question here? Lucia, do you have a question?
No, I don't.
Naz? All right, let's have one more homework question, then we will be going to new section. Try to love it. I will be back. Okay, you guys work on this. I'll be back in 2 minutes. So we want to construct 95% confidence interval with a difference in proportions who are, so again, yeah, I don't know how to explain it. I wish I was able to somehow tell you guys that without page of note is not possible. You need to have example, you need to know what is proportion. Well, anyway, so who are agreed between males and females using the fact that the standard error, so we have the standard error 0.08, standard error, I mean we have SE is this, and the formula is 2 plus minus, and difference proportion, we have like P hat of M minus P hat of female. This is between male and female. So that's what we need to do. P hat of M minus P hat of female. I know it's too much, Musa, and you know, what is this? Yeah, this is. So you're thinking about it. Ray, good, you're standing up. The remote control? Huh?
I think I'm onto it.
Oh, you're doing it? Very good. That's good, you're standing up. That means it's difficult. Anybody else solve this? Group G4, Stephen?
Huh.
For the difference, I got 0.12. I don't know if that's correct though.
You got 0.12.
Yeah, for the difference between the proportions.
So what is P of M? What is
P of M is
hat of
point.
M? No, which one did you divide?
I did 372 divided by 735.
No.
That's not.
This is a male, okay?
Yeah.
They said difference in proportion between male and female using, so male we have 372 divided by 1213. If you do this one, that means male and female are agreed. All right, does that make sense? So P of M will be that, P hat of female. So we have female, we have agreed, disagreed, don't know. They're saying how many of female are agreed. So how many of female, total are 1412, they're agreed will be 363 divided by 1412.
So for male, I got 0.270.
When you divide this, 372 divided by 1213?
Yes, it's 0.270.
Really?
Is it not?
372.
Oh, my mistake. I put 327 instead of 372.
I am like you, dyslexia. I'm always,
My bad.
that's fine, but we don't want to do that mistake. Very good. Very good. So we got this guy 0.31 I have, 0.31, and 363 divided by 1412 is 0.26. Good. So now
Yes.
the difference of these two will be 0.05. So it will be 0.05, which is this guy, plus minus 2 times 0.018. Asante, are you following us?
Yeah, I'm taking notes right now. I'm trying to do some calculations.
Very good.
Where did you get the 0.05?
That's the difference in
0.31
the
minus
proportions.
Okay, all right.
Very good. Please talk. I mean, you give me some energy, so you guys are following me. Then I don't need to draw anything. So now when you do that calculation, it will be 0.05 minus 2 times 0.018, which this gonna go here, and 0.05 plus 2.018 will go there. I think it will be 0.086 and 0.014. All right.
Wait, so the standard error is 0.05?
No, the difference. The difference.
Difference.
This one minus that one.
Oh, okay. You so take male, subtract the female, and you got 0.05.
Very good. Male and female.
Okay, thank you.
What about part B? Is that possible that there is no difference between male and female? So there is no difference. That means the difference should be 0, correct? And the 0 is not between 0.014 and 0.086. 0 is here, so it's not on the interval. All right. Asante, so here is a bootstrap. Here's a story about that with one sample, With one sample, we're gonna make some decision. So the outline. Do you guys have any question for me? Rough. So again, I'm assuming you guys are spending at least 1 or 2 hours a day or every other day on this course. I'm not assuming that you guys gonna start studying the same day that we have exam or the same day is a homework due. It's impossible. All right, let's learn some new terminology here. So bootstrap samples. So again, we have samples. Now we have bootstrap samples. We used to have sampling distribution. Now we have bootstrap distribution. So that's what we're going to learn right now. Standard error from bootstrap, 95% confidence interval using standard error from bootstrap distribution. This what that was the reaction of Sante. So now he said reality. So with bootstrap, we are able to do it. We only have one sample. You're gonna have one example. I mean, one sample here. Suppose we have a random sample of 6 people. So now you need to visualize. This is not my population. Please stop me if I don't make sense. Are you guys with me?
Yeah.
Yes.
Yes.
Okay. So this is a sample from the big population. And look at this one. This is an original sample. From this sample, I can simulate population to the sample form. So this is sample, that sample, the same sample, I can create a population on that. Bootstrap sample. Sample with the replacement from the original sample using the same sample size. So this gonna be, you're not gonna see me, you're gonna put them on the back or something that you're not gonna see at the computer. Will pick one. For example, the first one, let's pick this, like this person. We pick it and then we put them back and then pick another person. This person picked another one. So we made a bootstrap sample, same size, and we create a new sample. Any question here? Okay, let's have one question for you guys. Your original sample has a data value this. Let's say this is a sample. I have those are the data. I picked it from this population, 18, 19, 20. Is this correct? Is the following a possible bootstrap sample?
No, because it contains 22.
Beautiful, beautiful. This, but the bootstrap sample should come from this sample. 22 is not there, so this is not a good sample. Very good. The answer is no. What about this one?
No, because it doesn't have. I think it has to have the same amount of values.
Very
in the
important.
sample.
has to have same number. This is 1, 2, 3, 4, 5. Here you have 1, 2, 3, 4. Has to be same size. So this is no, because we are missing 1. What about this one? Don't guess because we had 2 no. This is going to be yes. Yes?
Yes.
Yeah, the number is the number of sample is correct, and all the number we see here, we also see it there. Excellent. So let's memorize something here. Bootstrap. A bootstrap sample is a random sample taken with replacement from the original sample of the same size as the original sample. Love it. Makes sense. You should mean. Second one, a bootstrap statistic. That means the average, the standard deviation, the proportion, everything is a statistic computed on the bootstrap sample. The bootstrap distribution is a distribution of many bootstrap statistics. Many, that means we're gonna, in the previous example, we picked 6 people, we're gonna have many of those sample to make some conclusion. Here's a better picture to view. Okay, so we all trying to come up with some conclusion for the population. But here there is no picture of population. We only have original sample. This original sample comes from a big population, your average height of entire Earth. So we take the original sample, which is only 1. We apply sample statistic. Good. This sample statistic, for example, we get X bar, we get proportion, standard deviation. All right, this is something that we can apply to the sample. But with this one sample, we are not able to make a conclusion about our population. What we do, we apply a bootstrap. Bootstrap said, go back to this one sample that you picked, this one. Now create random bootstrap sample. Good. It would be super complicated if you want to do it by hand, but computer will does it for us. If there are 50 people on the sample, so this sample is going to be 50 people. So you're going to pick one, put that person back, and get another one. Good. You're going to be so much putting it back in. So it's not possible by hand, but computer will does it for us. So we get one bootstrap sample, we apply the statistic. For example, we get X bar of that. Another sample, we get X bar. Another one, we get X bar. Then we graph it. Asante, does that make sense now?
Wait, I missed it. I'm sorry. My bad.
So you're following me.
I am. I've been up all day.
No, this is a whole better picture to visualize how we are able, with one sample, make a decision about population. So I was saying that this is the original sample. We ignore the population. We cannot access the population anymore. From the original sample, we make thousands of bootstrap sample. And we got the idea about how do we make a bootstrap sample. Then we apply statistic to each of them. We graph them. We will be something like this. Then we find like a X bar. We find the interval to make a decision about the population.
Okay, I guess my question is, where would I find the bootstrap statistic on StatKey?
Oh, that's a different question. I will. Let me finish this one. Hopefully we get there. Yeah, has to be
Okay.
a button to do that. So this is another picture to view. If you guys remember, before we always had population here, but population is odd. We are dealing with sample. I get bootstrap sample, bootstrap sample. For each one, for example, I get X bar, correct? I graph the X bar. This is bootstrap distribution. Same as sampling distribution, we have a standard error. 95% confidence will be 2 times the standard error. And statistic plus minus margin of error. Golden rule of bootstrapping. Bootstrap statistics are to the original sample statistic. Bootstrap statistics. So when you see bootstrap, you have to picture how we're going to make a sample. The statistic, all this statistic, it can mean like a 5-number summary, whatever statistic we're going to apply to that sample. They're saying bootstrap statistics are to the original sample statistic. As the original sample statistic is to the population parameter. So from bootstrap, we go to sample. From sample, we go to the population. So in our example, we only talked about the average, but we can apply any type of other statistic like proportion, difference in means. So the same idea we can apply to other parameter. So summary, to generate a bootstrap distribution, this is brand new topic for you guys. So generate bootstrap samples by sampling with the replacement from the original sample using the same sample size. Second one, compute the statistic of interest, a bootstrap statistic for each of the bootstrap sample. For example, if you're looking for average or if you're looking for a standard deviation or proportion, you need to apply to each sample, bootstrap sample. Collect the statistic for many bootstrap samples, 2 from a bootstrap distribution. Collect the statistics for many bootstrap samples, 2 from a bootstrap distribution. If the bootstrap distribution is symmetric and bell-shaped, which is most of the time this course, a 95% confidence interval can be estimated by a statistic plus minus 2 standard deviation. So same as before, where standard error can be estimated as a standard deviation of bootstrap distribution. Whew, this is 3.3. We have one more section and then we're done with chapter 3. All right, let's work on this. We have 15 minutes. I know you guys are tired because you've been studying a lot. Musa is here. Catherine is here. Elizabeth. Wow, 15. We lost 3 people. Any question for me? Any question for me?
No.
Only we have few weeks left to the end of the school. I don't want to stress you out, but part B, what population parameter are we estimating with this sample statistic? So population parameter, correct? How many do we have? In your note sheet, we have mu, we have sigma, we have proportion, we have rho, correlation, and yeah, that's it. So which one are we estimating here?
P.
Means rho, put a P, very good. So P, the proportion of all American adults that say it's wrong. Use the margin of error to give a confidence interval for estimate. Because all of them are similar. So now part C, use the margin of error to give confidence. So we're looking for confidence interval. You already know two formula for confidence interval. Here we have margin of error. So so it would be 0.44, which is what we have right here, plus minus margin of error, which is 0.03. Where is that over here? Part D is 0.42 a reasonable value of the proportion? Yes or no?
No, because it's below 0.44.
No, 0.42. Look at the interval is 0.41 to 0.47.
Keep forgetting.
Is here. So this is yes, but 0.50 is no. Good. So 0.42 lies in the interval. So it's a plausible value. But 0.50 is not. Those are the questions that you will see in exam or final exam. Again, I'm keep repeating myself. If your study will be super simple, if not, this will be miserable. Elizabeth? Are you there, Elizabeth? I have 15 people. I think for 12 of them are sleeping. This I am by myself. I see Musa. I see Ray.
I'm here.
I'm here too.
I'm here too.
Oh my God. I should make it complicated that all of you guys attend every day.
But I don't know if you want to see half of my face though.
Why? Why half?